Students, in this session, we have a discussion on angular measurements. Similar to the angular linear measurements, angular measurement is also one of the most important measurements in metrology. We can have the measurement on taper angle, surface angle of curvature of the surface. So like that, we can have the many angular measurements. So in this metrology of angular measurements, there are two instruments are used. One category come under the slip gauge. There is the angle gauges, which is similar to the slip gauge is used in the end standard, while the other type of instruments fall on the line standard. In metrology, there are some instruments used for measuring the angle. The most principal instrument is autocollimator and angle decker, alignment telescope, sine bar, vernier bevel, protractor. Now we have a look on the autocollimator. First, in the word collimate, the meaning word of the word collimate is to make something parallel to something. So we are using the optical system. So we making the optical rays parallel to each other. That's the meaning behind the word collimate. So that the collimating lens is used. So the instrument is called after the lens, collimating lens, collimator. Actually, in the autocollimator is used to measure the small angular deviation. So it is basically consists of two components. That is, one is the telescope and second is the collimator. So the two setup are combined in one instrument. And one of the main feature is it measures the angle deviation without any physical contact. So it is used to align the components and measure the deflection in optical system. Now, before dealing the explanation of the autocollimator instrument, now let us first know the principle behind the autocollimation. For that, the diagram can be useful. Here, a point source is there. So from the point source, a light is projected, and on the focal length of the collimating lens, the point source of light is there. So the distance between the O and collimating lens is the focal length of the collimating lens. So the collimating lens and the point source, from the point source, light rays are made to penetrate the collimating lens. As you know, the collimating lens is objective is from the point source, the light travels towards the collimating lens in any direction or orientation. But after passing it, the lens made all the rays become parallel to each other. So the collimated rays emerging from the collimating lens is made to strike a plane reflector like glass surface or anything. The plane reflector exactly set at 90 degree to the optical axis of the lens. Now, from the light rays inciding on the plane reflector again reflected back through the collimating lens and again reaches the same point source O. If the reflector is exactly 90 degree. For our consideration, if the plane reflector is tilted to the small angle theta to the vertical theta, again the light rays after passing through the collimating lens strike the plane reflector and is reflected back and reaches the destination O dash. Now previously when the reflector is exactly 90 degree, the reflected image, the rays again crosses the same point O. But here the reflector is made to deflect through the angle small angle theta. In the rays reflected through the angle 2 theta. Now the new destination is O dash. Let the distance between the O and O dash be x. Now due to the by the trigonometry, now we can form the triangle O dash O and the center of the collimating lens. Now we can have the triangle O dash and another point, the center point of the collimating lens. Now the theta is, the angle is 2 theta and the focal length is the f. Now considering the tan version of the theta, tan 2 theta equal to opposite divided by hypotenuse. So tan 2 theta equal to x by f and x equal to tan 2 theta and f. So when the angle is very small, the tan 2 theta can be written as theta into f. So by this empirical formula, in the distance x can be measured easily. So it is a measure of the angle deviation indirectly. So it is a principle of the autocollimation. Here, what are the important things to be noted while working in the autocollimator is, in the formula, there is no distance covered in the formula between the objective collimating lens and the reflector. So the f only comes into the action. So it is not taken into account the distance between the collimating lens and the plane reflector. So it has no effect on the measurement. But high sensitivity, a large value of x for smaller angle deviation of theta. So for that, larger focal length is required. Longer focal length is required. Here, although the distance between the lens and the reflector is not come into the account of formula, but if the distance is moving far away from the collimating lens, the reflected image will be vanishing and it not can come into the same destination. So there is some minimum limitation in the distance between the collimating lens and the reflector. These are some important consideration in the autocollimator. This is the principle of collimation. Using the principle of autocollimation, you can look into the micro haptic autocollimator. This is the construction of the autocollimator. So it is a point source of light, filter, condenser, diffuser, object reticle, then is a eyepiece. Here a beam splitter, objective lens. Okay. Now from the point source, the light is made to pass on the filter. So here the filter just observe the required light, required color and the required range of frequency of light only. So it observes another unwanted color types of light, anything. So only required color and the required type of light only passing through the filter. So remaining portion of the light is absorbed by the filter. Again, the condenser make the rays now somewhat parallel to each other. Then it passes on the object reticle. Again, it passes through the beam splitter. So the beam splitter split the incoming beam. One portion is goes to the objective lens and another is also reflect to the eyepiece. So in the eyepiece, a viewer can see the reflected image. Here, the same principle of operation is used. Here, if the reflector or for our consideration reflector, but in the metrology measurements, the reflector is replaced by the workpiece surface. So here for our consideration, reflector is there. So it is perpendicular to the optical axis. We have the same as focus as in the previous principle automation collimation. But if the workpiece or reflector is tilted, through certain angle, the reflected image, the rays also get deflected and goes on the eyepiece. So it can be seen in the two wires. One is the target wires and the setting wires. So by comparing the setting wires and the target wires, we can know the deviation from the measurement for the two measurements. So from that we can easily calibrate the angular deviation. So the longer the focal length of the autocollimator, the greater the angular reclusion, and the smaller the field review. A TV camera also can be installed on the eyepiece for better vision. Next is the instrument nozzle has the range of working is 10 minute of odd degree up to 10 minute of R up to 10-minute degree. Now let us look into the another device, angle decker. So angle decker is a modification of the autocollimator. Now we'll look to the construction of the angle decker. First, the simplified view. Now a lamp is there. It is a source of light. From the source of light, the light made to pass on the prism. So the prism is kept on a screen made up of glass. At bottom, the glass piece is embedded with a scale called illuminated scale. And also there's another scale, datum scale, across the center of the screen. So the light rays made to pass on the prism, and the prism reflects the light rays. It falls on the collimating lens or objective lens. From the collimating lens, the parallel rays work on the surface of a workpiece. So it can be considered as a reflector or the surface to be measured for the angular measurements. Now, let us look sorry, how the instrument works. So for the working, first the trial is made without keeping the workpiece. That is, only the reflector is there. Now the light rays passing through the prism and goes through the collimating lens, and its may pass on the reflector surface. Again, it pass on the glass screen. So the glass screen, the illuminating lens, after projecting by the optical system, it is tilted exactly 90 degree to the previous case. So the illuminating scale is seen tilted exactly at a 90 degree by the optical system, and also across the illuminating scale there is the datum scale. So the two scale intersect at a point like that. The two scale intersect at a point. So the point of intersection is noted. The point of intersection is noted. Now in the next trial, we first have the reading without workpiece. Now the workpiece, for that the angular measurements to be done, is kept on the base. So now the workpiece is kept, and again the light rays passing through the collimating lens and falls on the workpiece. Again the reflector rays pass on the glass screen, and the two scales are viewed from the eyepiece. It is microscope eyepiece. Now, if the workpiece surface is exactly similar to the reflector surface, the point of intersection won't be changed. But if there is any deviation from the workpiece from the reflector surface, again the point of intersection is noted. So for example, the point of intersection is in the first case is 20, that is without the workpiece. Again, on keeping the workpiece, we have the reading, that is the point of intersection of the two scale, that is the datum scale measures the 40. So the 20 and the 40. So now the angular measurement is the 20 difference, 40 is the 20. So 20 is the the measure of the angular deviation. So from that it can be calibrated. So, but the angle decker is not so precise as the angular autocollimator. So it has the accuracy of 1 oct. Then the its user is precision measurements and detection of angular movement among the others. So like that it can be used for many industrial applications, angle decker. So these are some discussion about the angular measurements in the metrology. Okay, I hope you have understood the concept. Thank you.